Okay, so the speed increases from u to v in a time t, acceleration is a. So yes, Ahan, how is equation 1 correct?
So S is equal to ut plus half at square, and
Correct.
acceleration is given by v minus u by t. Now, when
Good.
you put that in that equation, you get this equation.
Perfect. How is third right or wrong? Displacement of the body during the time interval t.
Sir,
Okay,
well,
see, third
y-
equation actually is wrong. So can you tell me what could be the right modification? So how do we find displacement using all these things? A small little tweak in this. Okay, see, let me write. Displacement is nothing but speed. Okay, S is the displacement. Displacement is speed into time, isn't it?
Yes, sir.
Now remember, this particular formula is only valid if the speed is a constant, right? In this case, speed definitely is not a constant. It is going from u to v. So what we will do, instead of speed, we will write average speed. So now tell me this, if an object is starting off with a speed u and ending with a velocity v, right? So average speed, just write it down. How do we find this? You just do u plus v by 2. That's the average speed. And if you multiply that by time, you will get the displacement. So that's why equation 3 would have been correct if you had a plus there.
so can we
So
use this?
yes, of course. But you need to be careful. Again, this will be only valid if the acceleration is constant, which in this case it's clearly given.
Okay.
Although you can use it, but I would recommend not, because some questions, if they give you acceleration is not constant, then this won't work.
Okay, sir.
Okay, and write this down, and then we move to equation 2. And let me know once done.
Done, sir.
Okay, good. And Anishka, anything for equation 2?
Not really, sir.
Okay. So can't we, one sec. Let's put acceleration as v minus u by t. Let's try to simplify the whole thing. Let's see, do we get the same thing or not?
Yeah, sir, it comes to that only.
It comes to what? The
It
first
comes to
expression.
the, no, the third one
Third
on
one.
side.
It comes to
Oh,
the third one. Not this third one, but our third one, u plus v upon 2.
fine, which means it matches, right? So in the exam, this is what you do. Just replace the acceleration and check. All right, so both of you now just take 1 minute, scan the whole thing and tell me any doubt in this question.
So when I had read the explanation, they had used gradient somewhere and something something.
That's the second method to understand. Should I explain that?
I did not understand that at all.
Ignore it. So close to the exam, do not learn a new method.
Okay, sir.
Just stick to the basic math. So what we have done here is acceleration is v minus u by t. That's it.
Got it, sir.
Great. Okay, so now I'll just tell you a small trick. Although, let's say if you don't want to do all of this in the exam, there is still a trick. So have a look. So in the question, it was clearly given that there is an object at speed u. After time t, the speed becomes v, and the displacement is s. Right? So we use the Stewart equation, s is equal to ut plus half at squared, and acceleration is v minus u by t. That gives you equation 1, right? Now the same entire setup. Okay, so Anishka, tell me the direction of acceleration in this case. In this diagram, acceleration is towards the right or left?
Right.
Yes, because the speed is increasing, so acceleration will be to the right. And right side is always positive, right? Now what we'll do, let me draw the same diagram, but with a small difference. So imagine the start point is on the right. So the object is starting with a speed v, and the speed is decreasing. Decreasing speed, final velocity becomes u. And now the acceleration is still towards the right hand side. So now if you apply the Stewart equation, initial speed now will be v. So we will write vt plus half. Acceleration will be negative because the speed is decreasing. And this is your equation 2. Observe, we have just flipped the whole thing. Anishka, check.
Yeah, sir, got it.
Yes, sir, got it.
Right, so if you flip the whole thing, v will be your initial speed, and which gives you equation 2. All right, so moving on. Okay, so that's it. This was the only route which you had sent, right?
Yeah.
But wait, you had sent something on radioactivity also. One sec. Some time issue, second something you had.
Oh, yeah. That, yeah.
One sec. Let me open my WhatsApp.
I mean, now,
Now you understood?
yeah, I understood now.
Okay, fine.
Yeah, but sometimes in the question,
Mhm.
when they want the answer in years, we don't convert the time constant into seconds, right?
It all depends on what they have asked. But whenever you are using any formula in physics, let's say n is equal to n naught e to the power minus lambda t. Watch. So in this case, if your lambda is in, let's say, per year, then make sure the time should be put in year only.
Yes, so exactly. So in this question, they wanted the answer in year.
Hmm.
That's what the mark scheme has given, which means
Uh-huh.
that t is in years. So shouldn't
Yes,
time constant also be in years?
time constant. Which time constant? The
Lambda.
half-life. Oh, that's not the time constant. This is decay
So
constant.
decay constant, sorry.
So if could you repeat, if you want the time in seconds?
No, if we want the time in years, that means
Mhm.
our decay constant must be in years, right?
Yes.
In the question they changed it in the mark scheme, which is why I got the wrong answer.
Wait, let's see what's the question. One sec. You had sent on WhatsApp, right?
Yes, sir. Do you want me to send it to you again?
No, actually, the thing is my laptop is malfunctioning. I'm not able to open. Wait, one sec. Let me try to open. Never mind. So, Mahan, give me some time. I'll open the question. In the meantime, both of you, let's start mechanics revision. Okay, here we go. Try this, both of you. First question.
Sir, is it A?
Decreasing at increasing rate. Okay, let's see.
And I think it's D.
Increasing at decreasing rate. So both of you have got completely opposite answers. So, check.
Oh yeah, sorry. I had a brain fog. It is D.
B, Bombay,
D.
Delhi. Okay, that is correct. So, why A?
So, sir, brain fog. But like, I know why it's D. Right.
Please don't repeat these mistakes in exam. It's silly mistakes. Next, question number 2. Try this.
So just one question. In the previous one, air resistance was not ignored, right?
Of course, yes. Air resistance is not ignored. Imagine, let's say air resistance is ignored. Then what will happen to the speed?
It will still be increasing but at a constant rate.
Constant rate. Amazing. Perfect. That's the
So
trick.
in a question like this where it's not specified, do we consider air resistance ignored?
So consider one rule. So if, let's say if they have not given anything, step 1, assume air resistance is not there, right? Make that assumption. And if you are assuming that, then no option will give you the answer,
Yeah.
isn't it? Then you assume the air resistance just to check which option fits in. So
Okay.
this is, I have placed this question. This is one of those rare questions where our assumption falls flat. But in most questions, always start with zero air resistance.
Okay, sir.
Now try this.